In this presentation, I will discuss the mechanical energy and the ability of cats to rotate their body while falling so they can always land on their feet. So just to start, there are 6 types of mechanical energies. So kinetic energy is the energy of motion, potential energy is the energy of relative position, thermal energy is the energy of the internal motion of an object's atom and molecules, while chemical energy is the energy stored in the structure of atomic bonding to form molecules. Electromagnetic energy is the energy of light and other radiations, and mass energy is the famous Einstein equation of E equals mc squared. But for this study, I only utilized 2 of the mechanical energies, the kinetic energy and the potential energy. As I already said, the kinetic energy is the energy of motion observable as the movement of an object. And using this formula, we can actually find kinetic energy using 1/2 the formula K equals 1/2 mv squared. While potential energy is energy that is stored within an object that is not in motion. And potential energy formula is just U equals mgh, or mass, gravity, and height of the object. Um, Another formula used in this is the conservation law. So where there are no outside forces, simply is the initial kinetic energy plus the initial potential energy equals to final kinetic energy plus final potential energy. Well, the conservation law states that the energy can be either created or destroyed. So that's how the formula is explained. Well, talking about cats, how do they turn like that? So the ability of cats to rotate their body while falling and to land their feet is called the riding reflex. The reflex is innate and every cat has it. Well, a cat, to make this happen, has to follow like 3 most important steps. The first step consists in like the cat has to bend in the middle, letting the front half of his body to rotate on different axes from the rear half. Well, in the second step, the cat tucks his front legs and extends his rear legs so the front rotates more than the rear half, rotating in the opposite direction. And the final step consists in extending its front legs and tucking the rear legs, forcing the rear half to rotate faster than the front half. After these 3 steps, the cat is parallel to the ground and ready to land. Well, that's the link for the video that I made. So we can see the cat being drawn from 1 meter. Okay. So these are the formula used. And in this study, I was looking for final velocity right before the cat landed, and the force that the cat had to absorb once he lands. So as I say, kinetic energy, potential energy, conservation law, and the Newton's second law was used to find force. Newton's second law states that the force produced by an object is equals to its mass times acceleration. So mass A. Those are number of the study. So since the cat starts from rest with an initial velocity of 0 meter per second, the initial kinetic energy is 0. And since the cat lands on the end of its pole, the final potential energy is 0 too. So we can actually erase K initial and U final. So writing the potential energy, the initial potential energy, and the final kinetic energy, we know that the mass is the same as the same cat. So the equation can be simplified, m can be taken away. So the final formula utilized is G equals 1/2 V final squared. So using our numbers and just plugging in, we get a final velocity of 4.43 meter per second, while a force using a mass of 5.5 kilograms and acceleration of 9.8 meter per second, we get a force of 53.9 newton. And this end my research.